A spherical gas container having an outer diameter of 4.5 meters and a wall thickness of 22 mm is made of steel for which its elastic modulus is 200 GPa and its Poisson's ratio is 0.29. Knowing that the gauge pressure in the container is increased from 0 to 1.7 MPa, determine the maximum normal stress and the increase in the diameter of the container.
So I already solved the answers for this problem. So for the A, the maximum normal stress, I have here 0.087 GPa, and then the increase in diameter of the container, 1.39 times 10 negative 3 meters. But before that, we need to write the given values. For the outer diameter, we have 4.5 meters, the wall thickness 22 mm, but since the unit of our outer diameter is in meters, we need to convert this to meters, so 0.022 meters. Next is the elastic modulus of a steel, which is 200 GPa, Poisson's ratio 0.29, and the pressure is 0 to 1.7 MPa. But since the elastic modulus is in GPa, we can convert this, so divide this by 1000, and then you get 1.7 times 10 negative 3. So find the maximum normal stress and the increase in the diameter of the container. So for A, we can solve this using this equation. Stress 1 minus stress 2 is equal to pressure times radius over twice the thickness. But since we currently don't have the value of our radius, we can solve this using or dividing our diameter by 2 and then subtracting the wall thickness. So, plug in the given values, 1/2 times 4.5 meters minus 0.022 meters, and then if you calculate this, you'll probably get 2.228 or 2.23 meters. So now, we can finally solve the maximum normal stress in the container. So, plug in the given values, pressure 1.7 times 10 negative 3, so don't forget to write the units, radius 2.23 over 2 times 0.022 meters, so cancel meters, and then you'll get 0.087 GPa. So for the B, or the increase in diameter of the container, we can solve this using this formula, D times strain 1. But since we don't have the value of our strain 1, we can solve or identify the value of this using the maximum strain energies theory formula, which is strain 1 is equal to strain 2 is equal to 1 over E times stress 1 minus the product of Poisson's ratio minus Poisson's ratio and then stress 2. So, factor out the stress, then you'll get 1 over E times 1 minus V times stress 1, or the max normal stress. So, plug in the given values. For the elastic modulus, 200 GPa, Poisson's ratio 0.29, and then the maximum normal stress, which was solved earlier, is 0.087 GPa. So if you calculate this, you'll get 3.0885 times 10 negative 4. So note that strain are unitless. Next is to solve or identify the increase in the diameter of the container, since we already completed find the values. Found. Then outer diameter 4.5 meters, the strain 1 3.0885 times 10 negative 4. So plug in the given values, D 4.5 meters, strain 1 3.0885 times 10 negative 4, and then you'll get 1.39 times 10 negative 3 meters. So that's all, and thank you.